All right, everyone, we are back, and we are going to go through our P set 2 solutions. A through C, what type of cell? Simple cubic, and BCC. Let's see. Number of atoms, 1. The answers will be the same for both. 2. Number of nearest neighbors, 6, 8. Nearest neighbor distance is 2r for both. Lattice parameter is going to be also 2r for simple cubic, and for BCC it's 4r divided by square root of 3. Next nearest neighbor distance is this for BCC. For simple cubic, it's 2r root 2. And the atomic packing factor is both, for both of these, is less than 0.74. Are any of the cells close packed? Nope. Are any of the cells primitive cells? Yes, simple cubic. Great. All right. And this is, I always have this mistake, or not this. Yeah, it's a mistake. I always have this typo. We need to calculate this for A. And right now, I'm just going back through the P sets and making sure that that is indeed corrected. All right. Updating my LaTeX and then getting it done. Excellent. A. Crystallographic directions. Let's go. So finish minus start. Finish point would be 1/2, 1, 1. The start would be 1, 0, 1. Actually, excuse me. It's going to be 0, 1, 0. So we're left with 1/2, 0, and 1, which will then become 1, 0, 2. All right. What about here? Let's go ahead. Our finish is going to be 1/2, 1/2, 0, minus our start, which will be 1, 0, 0. And that leaves us with minus 1/2, 1/2, 0, which will be equivalent to 1/2, 1, 0. Excellent. Here, our finish is going to be 1/2, 1, 0, minus our start, which is 1, 0, 1, which will leave us with minus 1/2, 1, minus 1, right? Which will then become 1/2, 2, 2/2. And then finally, this little guy right here, let's go finish it up. Our finish is going to be 1, 1/2, 1, minus the start, which is 1/2, 1, 1, which will be equal to 1 minus 1/2 will be 1/2, 1/2 minus 1, that's a minus 1/2, and then 0, which will lead us with basically 1, 1/2, 0. Excellent. Any close packed? Nope, they're not the 1, 1, 0s. Excellent. Now we've got planes. So, first plane, we don't intersect our origin, so our x-intercept is equal to 1. Our y-intercept never happens, and our z is equal to 1/2, so our plane is going to be 1, 0, 2. Here, we have to change our origin. Let's pick here. My x-intercept is equal to 1. My y-intercept is equal to minus 1. My z never happens, so we're going to have 1, 1/2, 0. Beautiful. We should indicate the origin. Are any planes close packed? None of these structures can't have close packed planes. So both those answers are nothing. Good. Or no. Planar density for the plane in C. So it's BCC. It looks like this. This side length, the top, is going to be ABCC square root of 2. This is ABCC, where ABCC, we defined before, 4r divided by square root of 3. Atom, 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 atom. So our planar density is equal to 2 pi r squared over ABCC squared times square root of 2. All right. Let's see. Draw BCC here. Boom, 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 boom. Draw this direction. So, finish minus start. So it needs to be -1. So it's going to be 0, 1, 1, 1, and then 1, 0. So start, finish. So 1, 1. Here's my start. My finish is going to be 0, 1, 1. So it's going to be like this. Beautiful. draw the -1, 1, 2 plane. I'm just going to get rid of these guys right here. Is that direction closed packed? No, it needs to be the diagonal. So we need to have a starting origin where I need to go back and also down. So actually, I'm going to go right here. So this is my new origin. My x-intercept is -1, my y-intercept is 1, and my z-intercept is -0.5. So -0.5, -1, and then +1, so that it looks like this. Boom, boom. There it is. Done. Draw the following directions. So let's go ahead and get it done. So 2, that means I need to have basically a 0. Finish, these are finishes and starts. 0 and 1, and the rest of these can be 1, 1/2, 1, 1/2. So our start is 1, 1/2, 1/2. So 1, 1/2, 1/2, and then 0, 1, 1. So it'll look like this for finish. The next one will be this, finish my start. Again, so this is going to have to be 1, 1/2. This is going to have to be 1/2, 1, and then this is going to have to be a 1 and a 0. So my start will be a 1/2, 1, and then my finish will be 1, 1/2, 1. And then we'll go like this. And then finally, so I'm going to multiply, let's see, 2/3. So multiply everything out by 3. So let's go ahead and start off with 1, 0. And then we'll multiply everything up by 3. So these have to be 2/3. And they both have to be -2/3. So I'm going to have a 1/3, a 1/3, and then a 1 and a 1. So 1, 1, 0, start. Then 1/3, 1/3, 1. Look like this. Done. All right, 0, 3, 0. Let's see. 0, 3, 0, 0, -3, 0. So let's go ahead over here. So we need 0, 3, 0, and then what else? 2, 1/2, 1. 2, 1/2, 1. 2, 1/2, 1. Excellent. To find our origins. So I'm going to do this one first. So we need to move basically to the left because x is never going to cross, y is going to be -1/3, and z is never going to happen either. So I'm going to pick, because I want to go back, I want to just go here. So this is my new origin, so it's going to be -1/3, so it's going to look like this from this new origin. And there it is. Done. Now for this one, x is equal to 1/2, y is equal to -1, z is equal to 1. So kind of the same thing, we need to move to the left. So, and we also need to move positive x. So actually I'm going to go over here. Positive x. So x is equal to 1/2, y is equal to -1, and then z is equal to 1. Done. Fantastic. Got it. All right. And that's pretty much, now it's what material we're working with. So we're given these ratios, or we're given these values. We know that that's the next nearest neighbor distance, and the nearest neighbor distance, so 3.39 divided by 2.94. That is going to be equal 4 times r divided by square root of 3. If we divide, that's our next nearest neighbor distance for BCC times 2r nearest neighbor distance. What will that look like? Voila, we got it, approximately. So 2.94 divided by 2, 1.47. Let's go into our periodic table. 1.47. So it needs to be BCC. So the integral of that first peak needs to be 8. 1.47, metallic radii, NB. That's our answer. And that is the rest of this problem set. Let me just make sure. Yep, that's what we got. NB, BCC, this integral is 8, and we're done. See you in the next video. Thanks. Bye.